Hello everyone, my name is Bogdan Amidzic. I'm technical director in Creator Studio, Belgrade, and I'm also instructor on Houdini course in Crater VFX Training Center. And today I'm going to show you how to do automated instancing in Solaris. Previously, I held lectures on how to set up a USD pipeline in smaller studios. And last of these lectures was my talk on Tokyo Houdini HIVE, in which I talked about new terrain tools in Houdini 21 and some of the techniques, how to use COPs for texturing. And I mentioned this tool that we developed for automated instancing. And basically what that tool does, it takes point cloud and it creates instances for you under the hood, so you don't have to do it twice in SOPs and in Solaris. Okay, so let's get to it. So first step would be to create a height field setup. And here I'm creating some masks for some of the trees that are closer to the river. And this would be willow trees. Here I use half Serbian, half English naming. Yeah, so at this point I'm setting everything up in Solaris. So creating output for height field scatter. Okay, and in Solaris importing height field. So in my Tokyo Hive you can watch about that in detail. So for the trees, here is the USD for willow tree. And here are the points for the scatter. So I will be creating instancer for that. So I don't need these points imported with SOP import. So yeah, this instancer will be complaining at the start until we give it points. So inside the instancer, by default, you can just object merge your points. And yeah, here it is. And we have it in Solaris. So we have proxy representation of these trees. And if I pin my viewport and switch back to SOPs level, I can tweak rotations, radius, and all of the other parameters of height field scatter. Okay, some normals. Okay, so basically I have to pin my viewport in Solaris in order to see OpenGL or Karma render preview. So here I'm just setting up some materials in Karma and adding some water surface. So back to our USD for the willow. I have a couple of variants of geometry variants for this tree. So some of them have Arnold materials and they don't work in Karma, but some of them have like proper shading and different geometries. So in order to facilitate that in the instancer, we can use node that's called explore variants, which would duplicate your assets based on the variants that are inside. So this node is a bit redesigned in Houdini 21. So you have to give it a variant set filter, and it would show you all of the variants that are present in the assets. Okay, And with variance selection filter, you can basically filter which one of these variants you want to load, and you can use stars and wildcards. Okay, yes. So in 21, actually, what was explore variance in previous versions is duplicate variance now. Okay, so you get, for each variant, you get primitive. And what you can do in instancer node, you can say for prototypes to use basically all of the primitives on that level. And they will be randomly scattered on these points. Okay. Yeah, so under the hood, for the orientations and scales, what Solaris is doing is picking up attributes that are present in the scatter points that are automatically created by HIVE scatter node. So, for example, orient, scale, and these kind of attributes. So here I'm creating another height field scatter for different type of trees. It would be oak. And yeah, so I have points for the oak and points for the willow, and I'm separating them, tweaking a bit my masks. So I have two outputs in SOPs, and in Solaris I'm doing the same thing for the oak tree. Yeah, I'm setting geo for the variance set filter, and here I will be selecting all of the summer variants. So star, summer, star gives me all the variants that have summer in their name. And yeah, hooking this oak in the prototype primitives. Okay, so I have now two instances. Okay. Yeah, so just have to rename them, not to be named the same. And here is my result. And here is the result in Karma. So I can even pin my Karma render and switch back to SOPs and do any kind of tweaking on my high field scatter nodes. So the whole process is going back and forth between SOPs and Solaris, and for all of my setups in SOPs, I have to create duplicate setups in Solaris. So next, I'm going to talk about how to import USD variants into SOPs. So regular USD import node has ability to import variants, as you can see. So we can choose between the variants, and we can set variant set as well. And we can load both of these variants that we are going to use, merge them, and in height field scatter, if we try to transform one of these, we see that actually we have two variants now in our HIVE file scatter, but we would need something smarter, and we would make our own asset loader. So if we dive inside USD import node, we'll see that it is basically LOP network and LOP import node. So we are going to create our own loader for the assets. So we're going to create LOP network inside, and there we are going to put our USD asset to load it with the file, put explore variants node, and set it. We'll set it later, and output node. And that goes in LOP import. We are going to import that output node. And we want to import all of our variants. So no matter how many of them are there, we want to get exactly one primitive in SOPs that corresponds with one variant in Solaris. Okay, and in our explore variants, we are going to set it to work only with geo variant set. And now we have a number of primitives in SOPs. And now the only step that's left to do is to, so now we are going to create digital asset out of this, to put it in some place we want. So when our digital asset is created, we want to give to user parameter for choosing which USD file to load. So we are going to choose our file here and to link it to our file node inside our LOP network. So this is the same thing that USD importer is doing. So okay, and in our wrangle, we would want to create two string attributes. One attribute would be the path to our USD file. So we want to have that on our primitives. And other attribute would be variant. So it would be only the part of name attribute. Okay, so here it is. So in our SOPs we have information which USD asset it is and which variant it is. So this is very important because we want this to pass along through our height field scattering. And one parameter also that's exposed is variance set filter, so user can choose which variance they want to load into SOPs. So here I'm just picking, let's say, summer and summer spring. And here, if I scale one of these, we see that in height field scatter everything is working correctly. So I can save out my assets. So this is for the oak. And this one is for the willow. So we choose variants we want to load. Okay, and both of them are loaded and scattered. So benefit of this is that inside SOPs we see exactly what we are doing. So we don't have to switch between SOPs and LOPs in order to see what are we doing. Okay, so for the output of this, we would just take our points. So remove volumes. Okay, and we have our point cloud, and yeah, so the thing is we don't have our USD primitives because we need to unpack it once. So height field scatter actually packs our primitives. So if we do unpack only once, we'll get to our USD primitives, and we have all the necessary attributes. Okay. Okay, so next step would be importing that into Solaris. So what are we going to do here is, if we try to import these trees in Solaris, we'll get something. So we'll get a bunch of empty primitives. So that's not what we are going to use. So in Solaris, we are also going to make our own loader for this. So we are going first to create SOP network inside our LOP network, and there we are going to process our incoming points or packed primitives. So first thing would be to import or to object merge our trees point cloud or packed primitives. and here we have everything we need. So out of them, what we can do is we can extract on one side we can extract points, and on the other side we can extract what are USD files that we need to load. So the way we are going to extract these two primitives, these two USD paths, is we are going to create a wrangle, which is detail wrangle, and we want out of this USD asset attribute list to extract two values that are unique. And the way I did it here is I'm going to create empty string array that's called USD array, and I'm going to iterate through all of these primitives with a for loop. And basically I would, if there is attribute value that's different than the ones that are already in the array, then it will be added to array. So I'm reading out USD file attribute and then saying if it is not in the array, please append it to array. Okay, so that should do it. There is a small error. Okay, yeah, so I have my string attribute and I can check it just, yeah, now I have it. So I can check it by creating some attribute. So I had variables, now I have attribute and it's empty. So why is it empty? Okay, USD asset, so USD asset, not USD file. Okay, so now we have it. Okay. Okay, so next step would be to iterate on these files and to create some kind of dummy primitives. So I will just create 2 points that are placed in the 0, and I would create primitive out of these 2 points. So add prim. So it could be polyline, it could be anything. So this is just a dummy primitive. And for this primitive, I want to set some attributes. So I want to set, first of all, USD asset attribute that matches our USD file. Okay, and there is some slight error here. Okay, I should say that USD files is string, so you have to do it in vex. And now I have a bunch of these primitives. So there is one error. So when I used find, I should set, so if it is less than 0. So now I have 2 primitives in SOPs, and these 2 primitives have USD asset attribute. And next attribute that I would want to create is a path attribute. Yeah, or in this case, name. Okay, so this is just extracting the last part of our USD assets. So stripping USD and stripping whole directory structure. So now we are going to set up path attribute. So basically we can say, let's say USD files plus USD name. So our path would be USD files slash the name of the asset. So now when we import that back into LOPS, so SOP import and just import it. Okay, relative reference. Okay, I have two curves objects and they have proper paths and they have primvar that's called, we'll see it here. Okay, we don't have it. Why don't we have it? Okay, so what's happening? So by default, USD import ignores all attributes that have USD in their name. So I'm just going to override that. So now I have USD asset primvar on both of these primitives. The only issue is that the length of these primvars is 2. So for some reason they are written as array. So both of these primitives have both of these USD files in primvar. So there is a way to handle that. So in SOP import there is option. Okay, but I'm ignoring it now. Okay, so I'm setting up my for each loop and I'm going to take care of these primvars later. So for loops inside the LOPS can be a bit mind-boggling. So we want to iterate through each primitive in second input here. Yeah, and we're just going to say USD files star. Okay, so it would iterate through both of these curves, and on the right, on the third input, it will do something. And here I'm just going to add some primitive just to see if it is working. Okay. So if I add primitive, it would create this primitive, the number of iterations I have, and since it's overwriting itself each cycle, it would create it only once. No? But now I'm going to do something useful with this. So I will create a Python script, and inside that Python script, I would just, for start, I would just do some simple testing. So this Python script would be run in each cycle of this for loop, and like the main power of this whole USD Solaris environment is that with these Python scripts you can do anything. You can create USD primitives, you can reference primitives, you can traverse through stage. So this node is very powerful, and it's very good to get familiar with Python inside USD environment. So the first thing I'm going to do in this Python script is I want to know on which primitive we are currently iterating. And there is, in documentation for loops, there is Python code which gives you current iteration value. So that would be the path of your primitive. So it's stage get prim at path, and we want a context option that's called iteration value. Okay, so we are going to get like object for our primitive, and then we want to do something with it. So what we want to do, so yeah, here is that iteration value. So what we want to do, we want to extract prim var from the current object, but first thing we are going to print out input prim, and in our log we are going to see that we are actually iterating through each one of these two primitives. That's fine. So next thing we want to get prim var of the primitive, and there is thing called prim var API, which would require us to import some of USD modules. So we need to import USD geometry. Okay, from Pixar, import USD geom. Okay, so yeah, so we want to get this like prim vars API object, and then from it we want to get certain attribute that's called, so get prim var USD asset. Okay, there is slight error, typo. Okay, and we can print out the value of our prim var. Okay, yeah, so we need to do one additional get in order to get actual value, and these are printed prim vars. And yeah, so here we are going to see, yeah, so we have for both of these primitives, we have actually two values, values from for primvars, so that's not correct, that's not good. So as I mentioned, in here in SOPs, everything is correct. Yeah, so here everything is okay, but when imported back into Solaris, something is mixed up. So in the SOP import node, there is actually option which would sort that out. So the option in SOP import is called import as single element, and we are just going to say that this attribute is going to be imported as single element. So now we have it correct, and now if I do my printing, we'll see for two primitives we get exactly two USD paths. So I can just print this out in a bit nicer way. Okay, so next thing I'm going to do is to create asset name. So similar as the thing that we already did in SOPs, so some splitting of the paths and assets. So yeah, so we, based on that, we would want to create new primitives, and this is the power of USD Python API. So we can directly into this Python node, we can define new primitives in our stage. So here I'm defining prim that's going to be placed on root plus asset name, and it would be the type of Xform. So you'll see that I created two primitives now with this Python script. And on these two primitives, I would want to reference our USD files. So basically, for my USD primitive, for my newly created primitive, I need to do get references and then add reference and the path of my reference. Okay, so I would not need this, so it would be simple. So just the path of the USD files. So basically, with this Python script, I referenced proper USD files based on what was coming from SOPs, and now I can basically repeat the same process as in my loader for geometry. So we want variant set called geo. Okay, I made some mistake. Yeah, it should be here. Okay, so now I have all of the variants for both of these files. Yeah, so it should be set on duplicate now. Okay, and for the destination prim, I could set it out. It's okay. Yeah, so they are here. So all of the variants are loaded now for both of these trees. So now that's ready for instancing. Okay, so I can hook instancer here, and yeah, for the instancer on the left side I would need my points. So basically I need, for each one of these trees I need a point, and on this point I need to preserve my some of my attributes. So instance points, and now if I hook them into instancer, okay, relative paths, okay, we have some errors. Okay, so yeah, wrong thing imported in instancer, and still we have error because we need to tell it to use first input for the variance. Okay, so what we can say is basically use all of this and associate based on the name attribute. So now we have some errors, but okay, yeah, so it's complaining that it is missing name attribute, and if I look at my points, they don't have any of the attributes. So basically what I need to do is I need to promote name attribute, and okay, it's still complaining. So basically, to make things simpler, I would rather place this instancer after the for loop, and now it would associate names correctly. Okay, yeah, so and I will just switch it to use second input. Okay, so here it is, and basically it's doing its job, but orientations are pretty much the same for all of this. So what I would want to do is I would want to create orientation attribute for these points. So basically we can extract primitive intrinsic from USD primitives, and yeah, we would use prim intrinsic transform. Okay, we'll iterate our primitives, and we would create orient attribute using quaternion function. So basically it takes a transform matrix as input, and you get quaternion, and then we can promote it to points. So now on our points we have orient as well. Okay, and now in the stage we have our orient working. Okay, fine, cool. So next thing would be to have the scale. And in order to extract the scale, if we have transformation matrix, we can extract scale by using function that's called crack transform. And yeah, so it can be a bit tedious to use it, but in our case we need first two arguments would be 0 and third argument would be 3 or 2, we'll see. Okay, and yeah, we use position and for both pivot and position, and last argument is transformation matrix. And yeah, so we have it, and I see that values are a bit strange, so they shouldn't be like this. So let's see. Yeah, third argument should be, let's see, so C for the scale equals 2. Okay, yeah. Okay, so now we have our scale. So if we look at our instancer, and we just need to promote it as well. Okay, so we have our scale as well. And because it's vector, it could be a non-uniform scale. Okay, and yeah, what we would want to do at this point, we want to import our trees from SOPs unpacked, so this wouldn't do it. So I'll just unpack them in SOPs and see. We want to compare what our instancer is giving, and okay, so we want to go to our SOPs and basically unpack these trees to like totally row geometry. So we'll see trees row geometry, and we want to import that into Solaris to compare against. And okay, not working still. Yeah, so I need to unpack USD to polygons. So that's the thing, because these are USD primitives. And yeah, so it takes some time, but here they are. So they are now row geometry, and now if I go to my instancer, we'll see that they are a bit different. So the difference now lies in the location of the pivot, and we need to see how to handle that. So the thing is that when we loaded our asset here, pivot is being set to the center, and that's not correct. So we need to set it to origin, and here pivot location, we just set it to origin. And now when we switch to Solaris, let's compare it now. Okay, so now it's half working, and that's because of that's because Okay, I didn't save my asset, so I suppose that's the problem. Yeah. So if I just save it, because the other tree has asset that's not locked. So if I just save my asset, and yeah, so both of them now have pivot set to 0, and in my in my loop network, when we compare these two, we see that they are matching perfectly. Okay. And yeah, in the end, I didn't use this variant attribute because everything was running through the name attribute, but you could use it if you want. And now the only thing that's left for us is to save our digital asset. Okay, it's complaining that some paths are not are absolute, so we'll just have to deal with that. So what we want to promote, we want to promote input points to our attribute parameters. Okay, yeah. Okay. So it's yeah, just needed a moment to refresh. Okay, yeah. So here. Yeah, let's just set it to do. Oh, it's empty. So let's set it to do to input into this object. Okay, so now it's working. Okay. And now our instancer is working. Fine. Okay, so next thing that we would promote is next thing we would promote is the path of our instancer. So we want user to have control over that. Okay. Okay, we'll deal with this later. Oh, it's that one. So this is correct, and yeah, we need to get rid of SOP import 2. We don't need it anymore. Okay, so now when we save our asset, basically, yeah, our instancer is created based on the name of the node, but we can set it up like however we want. And now we can get rid of these nodes and just hook our instancer. And yeah, so okay, one more step that's needed. We need to keep incoming geometry. So just merge our instancer back to the main branch. Okay, fine. Cool. So that should be working. So no matter how many USD geometries we load into SOPs, we are going to get perfectly matching results in our Solaris on one click. So that's the main purpose of this tool, and we used it on many of our projects, and we added some more functions to it, like getting rid of the proxies and creating even simpler proxies, and time offsetting, and all of other like useful stuff. Okay, so yeah, in our SOPs now we have representation of what are we doing. We see our trees in SOPs. We can get rid of some of these nodes, okay, and we can add another tree, so why not? So let's see if this is working. So I'm going to create basically split this willow into two like parts. So based on this mask, I would keep willows. Okay. Yeah, I need to clamp. Okay, and inverted mask, I would use it for the other tree. So something like this. So we want to load another asset. Okay, here it is. Let's see what's inside. Okay. Okay. So let's make it more dense. Okay. Yeah, and for my oak trees, I would reduce their range. Something like this. So there you have it. This is how that instancer asset was created, and we used it for a bunch of our projects. And yeah, in some of the next tutorials, we might extend talk on this, or in the comments write me if there is a theme regarding Solaris and USD that you would like to hear about. Thanks.